Hi and welcome. This time around we've got a project for a customer where we're going to be making some dog treat ejectors. Basically they have a square matrix of stainless steel 20 by 20 grid that they use to cut out the individual square dog treats, and then they want something to be able to eject all those dog treats from that square grid. So we got to cut this guy down. We need to be 17-inch square. The customer sent me these cutting boards, which are 24 by 18, so they need to be 17.1 square. So we will be doing that, and that's why I've cleared off my table saw here, which was no small feat. That is crazy pain in the butt, because I have every square inch of my shop filled. Anyways, so we need to cut these down that way because that's probably the quickest and easiest way. And these are polypropylene instead of high density polyethylene, which is also, well, it's an alternative to high density polyethylene, which is also used for this sort of thing. So basically we're going to have to make a jig that will hold down and allow me to incrementally cut these, because there's 40 slots per board and I've got to make 2 boards. So the jig is going to have a crossbar that will not only hold the board down, but it'll also automatically align the previous slot you just cut. And then if I have the cutter always spaced a certain distance, then I'll just be able to, increment to the next cut, do the cut, slide up, align with the new slot, and then do the next cut, etc., etc. Although this is big enough that I'm going to run out of mill travel, so I'm going to have to flip it 180. Fortunately, it's perfectly symmetrical, so I won't have to do any new measurements or anything like that, so that's a huge plus. So the first thing we're doing is making a jig. So let's head on over to the mill and work on that. All right, first up I need to characterize the width of my slots, my T-slots in my milling table, and they're just machined, so I need to, I'm using them the parallel in this direction, so not parallel, but adjustable parallel, so that I can get an average of the thickness, because I want to make a fairly tight fit. They tend to be pretty reasonable. I think they're within a few thousandth over the lengths kind of thing. I haven't actually measured them with an indicator. I probably should do that at some point. So we need to know the width here, and then I've got to figure out how deep I need to go from my fixture plate, which there will be 2, one on each side of the polypropylene board. And basically what's going to happen is they'll have an alignment slot that fits down in the T-slot here that you can tighten down. And then there'll be a bar that goes across the board with a 1/4 inch wide slot sticking down, or protrusion sticking down, that'll fit into the board. And then basically I can lift that up, move the board over one slot, put it in, mill another slot right below that one, move it over, etc., etc. So first up, figure out what this width is, and then figure out my stock size for my fixture plate. Well, the measurements are a bit more accurate than I thought, or rather, not the measurements, but the consistency of slot widths more accurate than I thought, because I measured multiple slots, all 3 as a matter of fact, in different spots, and they all tend to be right on the money, 0.631 with the calipers. Now, I didn't do it with micrometers, but I don't think I need that kind of accuracy for this, nothing close. So I'm kind of impressed. They're actually better than I thought. So we're going to cut out the raw stock for the fixture plate, and we've got to load it up here in the vise. We need to cut some 1.3 inch final dimensions, so we're going to go for 1.5 inch thick slices out of this aluminum stock here. We're going to use our Baco Easy Cut blade. Now this is kind of a fine pitch for such a thick piece of material. I considered replacing it, but I really want to give this guy a test because they say it works in all kinds of materials. I think it'll be a little bit, well, certainly be a little bit slower than it could be, but let's just give it a shot here and see how it cuts. Got my blade tension set properly. It's going faster than I thought it would with such a relatively small pitch. Bring it back. All right, so there's the cut with the Easy Cut blade, and the finish is all right. It's nothing to write home about. It's about 10 teeth per inch. I measured it. They don't actually spec it that way. So what I'm going to do now is I'm going to swap in a 4 to 6 tooth variable pitch blade, and we're going to try the same cut. This took about 8 minutes to cut all the way through this. I didn't measure it very carefully, but it'll be interesting to see what a much coarser tooth blade does with the same material. So let me load up the blade, tension it, and I'll bring you right back. All right, next up we have the Baco 4.6 pitch blade, and here's the first cut. I'll leave it sitting aside here. You can see that's 4 to 6 variable pitch bandsaw blade. I'll be using the same pressure, feed pressure right now. That'll probably need to be adjusted because I'm not sure. I've never used this blade before. Normally you'd break in a blade so you don't damage it, but aluminum doesn't really break in blades, so at least that's my understanding. I could be wrong about that. I'd go check it for yourself before you potentially ruin a blade. But my understanding is aluminum, and I think even when I talked to the Baco rep, he said the same thing, that you can't really break in a blade very easily on aluminum. So I'm not going to worry about that. So let's just give this cut, and it should be a lot faster because there's much bigger gullets. I might have to increase the feed pressure a little bit because this blade can really use it, I think. I'm not terribly experienced, so we will find out. Well, with this low feed pressure, it's already a lot faster. Very smooth cut. As a general note, this material is 3 inches thick, and typically the thicker the material, the coarser the blade you want so that you can clear your gullets. So the previous blade might not have been ideal, although they designed it to work as a generic solution. So it actually performed reasonably well. I didn't have too much clogging. There was a little bit. Every once in a while you hear it a clunk, and I think that's because a tooth gets clogged with a chunk of aluminum. So I lightened up the feed pressure. I've increased the feed pressure a little bit. This one's cutting much faster, and so far no tooth clogs that I can tell. 250 or so surface feet per minute, which was same as the other one. All right, cut complete, and took about 1/3 the time, which makes sense since it's 3 times coarser tooth pitch. I assume that means it takes out about 3 times as much material per bite, but I did increase the feed pressure because it seemed like it was just sort of skimming at the lighter feed pressure. Here is the 10 tooth per inch easy cut blade, and here is the 3/4 pitch Baco blade right next to it, and here's the blade itself. And you can see that the finish is a little bit coarser. Not a huge amount, not as much as I'd expected. Pretty decent cut and pretty square cut, pretty nice. These match really nicely. All right, so next we're gonna head over to the mill. We're gonna square up these blocks, and we'll continue with making the fixture plates, plural. All right, so I've pre-dimensioned the blocks that I'm going to use. I'm using aluminum because this is just a quick project. If I was doing more than just a few, I'd want steel because the aluminum would wear pretty fast going into the hardened ways of the bed. So first I'm going to remove all the material down 3/10 of an inch, and I'm going to leave a registered relief protrusion here that will mate with the T-slots in the milling table, okay? And that will help align these with the milling table perpendicularly. Then I will flip them over and clamp the vise on that new protrusion, and I will both do a 1/4 inch groove for the alignment of the piece I'm going to be making, as well as I will face one side with the side mill and make them perpendicular to my direction. That way all registration's done for me automatically, which should be pretty handy. I've got a 1-inch end mill in here, and it's going to go just under 3/10. I'm going to leave a little bit of cleanup at the end. I'm not quite sure how this is going to work out. I'm going to start with a light pass and work up to it because this is a pretty big end mill. Based on the Niagara Niagara cutter calculator, it says I should have this about 1400 RPM or so, and that's at the low end of surface feet per minute, because for aluminum it says 500 to 1500 surface feet per minute for high-speed steel cutter, which this is. So I don't know, this whole thing seems a little crazy, but we're going to give it a shot and see how it goes. I'm going to go very lightly and by hand just to get a feel for how this is biting, because this is a huge cutter. And I know that it's different than like a face mill, but there's a lot of engagement along the side here, and I've had problems in the past, so we're going to take it easy. So we're conventional milling this direction. It's actually not a problem at all. I could definitely take a bigger bite. Now I know when you've got two parts in here, you got to be very careful. They're dimensioned accurately, and I did a really good job dimensioning them so they fit in the vise very snugly, both tightened at the same time, which is good. All right, well, my conclusion is that a 1-inch end mill with the big giant Weldon shank holder on it is too much stick out and provides too big a torque arm, so there's a lot of pressure on the spindle. So I think if I had to do this again, I'd use a 1/2-inch end mill, which I might for the other side switch to and just compare. I bet I can go a lot faster. Last pass on this side. We're going to go very slowly. We're only taking about 10 thousandths depth and 10 thousandths width. Just to do a sanity check to make sure that I got this depth right here, I deburred the edge, and I'm taking my depth mic and measuring it, and we're 1.74. So purposely left it a little large. We'll go and clean up the last bit at the end. So now we're going to go do the other side. Rather than set up everything, I'm just going to suffer through with the 1-inch end mill. Don't really think 1-inch end mill is a good idea on a small mill like this, although there's something entirely possible there's something I'm missing about how to use it properly. I just can't get a good finish out of it, and it is really rough on the machine, sounds like. All right, one massive mess later, the bottom is finished, so we can flip these over, clamp it by the slots I made here, and do the other side, and that'll make the other side parallel, and then face off these sides, and that'll make them perpendicular, and we should be good to go with the fixture. We need to drill some holes for some T-slot nuts and that sort of thing. Shouldn't be a problem. All right, so I've got the two fixtures mounted by the part that fits in the T-slot on the mill, and that will keep this alignment, since the jaw is aligned with those T-slots. Then when I do my 1/4-inch grooves on either side, they will be lined perfectly. I've labeled left and right to point which side is the perpendicular side, and I'm going to take a 1/2-inch end mill and just clean up the sides of each one of these on this outside here. So this piece will end up over there, this piece will end up over here, if that makes any sense for you. All right, so here I am just cleaning up one side. That's a nice finish, and we're done. So now we can do our 1/4-inch slots. And I think I'll do two. All right, so we're going to do the slots, and we're going to do symmetrical slots on either side, which gives me options of where to put the mounting bracket, and since it's symmetrical, it won't matter. It's symmetrical about the center, so that should be good. And we're going to start by going 100 thousandths depth of cut. This will clean up the edges and make it so that inserting the guide make it easier, because we're going to chamfer these 5 thousandths down. Other than deburring, we just need to pop a hole in the middle of the guide that fits in the T-slot, and you see me drill lots of holes. So I'm just going to drill this and bring you back. I already drilled one over there. And this part should be done of the fixture. All right, here's the two alignment fixtures. This one's the left, this one's the right. The edges that are flat or parallel to each other are the inside edges. The outside edges are probably close, but these are the ones that were cut referenced to the slots. So these don't wiggle hardly at all. Tiniest bit. And so when I lock these guys down, it'll be more than accurate enough for this project. So next, we need to cut the crossbars, that the crossbar singular that fits in here that also goes across the board. Thanks for watching. Hope to see you in part 2.